Good morning. I hope you're doing well. It's been a minute. Yeah, it's been a good last 2 weeks, I think, and I'm very excited to share the changes that I've made to Jugglebot with you all. I hope that you have all been well since the last stream, and yeah, let's get into it. So the first thing that I want to mention is that I have made a change to Zulip, and I've added an open problems stream. So if we go into Zulip, I have the desktop app, which is quite nice actually. I don't know if you haven't been on Zulip before, I strongly suggest joining our group. We have 96 members right now, so we're very close to the triple digits, which is very exciting. But what I want to mention now is this open problems stream, where I am intending to put all current problems that I am facing right now, and I just want like some sort of fix for them. So if you are interested in helping out with Jugglebot in any way whatsoever, this stream is like the best spot for you to kind of hang out and see what's what. Right now, one of them we will talk about a little bit later today, in like 20 minutes or so. And the other one, I don't really want to go into detail on right now, but it's interesting. It's good problems, and I'm keen to see what solutions come up for them. But yeah, so if you're keen to help out, definitely check out the open problem stream. I'm hoping that it will make it a lot easier for everyone to kind of contribute where they want to, and also to make it really clear where the problems actually are. But yeah, up to you. Yeah, super exciting update with the catching, because it is now working. And I was going to show you in person with the actual thing, but it's really fiddly to set it up, so I figured this GIF is probably just a better way to do that. But yeah, it's so good. Like, I've had to make a couple changes with how everything was working. So previously I was using this kind of setup, and this had like the house on top of it to protect it from balls landing on it and everything else. But this was the original, the previous hand motor, where it was sitting on the base nice and flat. The string went around this spool and went up to the platform. But this motor just has way too much inertia. Like, no matter how hard I would throw the ball down, it would still just recoil off of the hand, because it wasn't coming in with enough force or enough momentum to get this moving. But I have changed over to these teensy little tiny drone motors, which have like zero inertia, and now it works great. So maybe I'll give you I'll show you how things are set up on the robot itself. You get a bit of a spoiler for in a sec. Actually, no, I'll show you. I don't want to spoil the surprise. But yeah, it's a very similar setup to this, where there's just like a motor, a spool, and yeah, stringers around the spool. Very basic for now, because I just wanted to like get an idea of how things were working, and I will soon change things around a bit, but we'll talk about that more in a sec. But so what's actually going on here with the catching is it's so straightforward and so easy to set up with these new motors, because I can just tell the hand to be at the top of its stroke, and then like say the maximum torque that you can output as the motor is a small amount, and then I just drop the ball in, and because the motor can only exert such a small force, or torque, it just lets the ball overcome its initial inertia and just goes down. And just by tweaking that torque limit value, we can tweak how stiff the hand is, and yeah, make it more or less capable of like catching higher or lower throws. And it's just so clean and so easy. It actually just works. It's so good. And also, in case you're wondering, so these motors are drone motors, and they're very small, and they're not like super punchy. Well, you wouldn't really, I at least wouldn't really expect them to be, but I've been very surprised by how well these can throw as well. Because obviously, like, if it can catch, that's one thing, but if it can't throw, then something would need to change. But these can throw, and maybe actually to prove it to you, I should have put this GIF in, but I'm working a little last minute today. But you can see, let me put this in here. What? Oh, it didn't repeat. That's annoying. So we can see it can throw, but I couldn't get the camera set up in the right spot to actually see how high it went, but you can see I had the tape measure there, and I only extended the tape measure to 1.3 meters, and the ball went above that by like a pretty decent amount. So I feel like it can throw to, hey John, I'm going to mention you a little bit later, you're going to get a nice shout out. Yeah, so it can throw at least 1.3 meters, which is the same height that I can, if I'm really pushing myself, do 3 balls in one hand. So in my mind, that means that once this is working, it's not impossible that this version of the robot will be able to do 3 balls in one hand, which is very, very exciting. And I'm very, very keen. And it's so close. Everything is very, very close, as you'll start to see as we come along. But yes, catching is working, which is extremely exciting. So, in slightly worse news, the old ODrives are still wrong, still broken. I don't know why, because I changed the can, so it's a couple weeks ago, crackling noise, can transceivers all broke on all of the ODrives. I later found out, I measured them all, and they were all broken. And so I replaced all of them, and massive, massive thank you to someone whose name I can't remember off the top of my head right now. I think David, who was suggesting, my previous plan was to basically buy cheap little boards like this. These are like the normal CAN transceiver boards. I was planning on buying a bunch of these off of just like Amazon or something, and taking that chip off of the board, because that's the brains of the CAN transceiving. I was planning on taking that chip off of these boards and then putting it onto the ODrive boards. And I am so grateful that someone whose name I can't remember was suggesting that I buy, instead of buying them like this, I buy just the plain chip, and it comes as like I'll show you. They come in like a strip like this, and they're all just kind of like tucked in there. And oh my God, am I grateful for that suggestion. There is no way I would have gotten 4 of these chips off of their boards in a non-destructive manner. What I ended up resorting to, because I had these plain chips, I just ended up using side cutters to just cut these off, and then using my soldering iron, just like got the remainder of the little tab out of there. And that was so much easier. Even just soldering them on is pretty tricky, because there's stuff, I mean, these boards are a bit different, but there's always stuff like right next to them, and they were not trivial to solder. But I did, and they all seemed to work. Like, all of the soldering was fine, all of the connections seemed correct, but for some reason, they still don't work, and I don't know why. So I replaced them all of them, yeah, as I said, were broken in some way. Some of them had like CAN high pegged to ground, some of them had CAN high and CAN low pegged to each other. One of them had VCC pegged to ground, which was not good. But yeah, after fixing them all, they still don't work over CAN. But I think they work over USB, which is interesting. So I set everything all up again with all of the old ODrives, did all of the wiring again, got it all ready to go, turned it on, all of the legs moved up, so everything seemed to be working, and that wasn't happening before. But there was no CAN communication from any of the ODrives, and I don't know why. I didn't try controlling all of the ODrives over USB at the same time, because my code isn't really set up to do that, and I don't want to be doing that anyway. So I haven't actually tested if they do in fact work over USB, but they can control the motors, and they appear to be more functional than they were before. So I don't really know what the problem is, but I don't care, because I'm going to let dead drives stay dead. And if I have a project later on where I need the ODrive 3.6s, then I'll try to recover them. But to be honest, I've done as much as I am happy to do right now, and we are moving forward with ODrive Pros, which are so much better than ODrive 3.6s. I remember a little while ago, I was looking on the ODrive shop, and they say that the ODrive 3.6s are not recommended for new devices. And I remember thinking like, they say that, but like, they can't be that bad, right? Like, they still work, they're still good, they're still ODrives, so they're good. But the problem, but I really wanted to get the ODrive 3.6s, even though they're not recommended for new devices, because they're so much cheaper. Because it's like $200 to control 2 axes versus like $230, these are US dollars as well, to control 1 axis. So it's more than twice the price to control the same number of motors, but it's definitely worth it. They are so much better. So in no particular order, some of my favorite highlights of these ODrives are that the cable clips are bomber. They've got these like Molex connections for all of the cables, and they're so good. They just clip in, make a nice satisfying little like clink, and then they're in, and they're really easy to remove. They seem to be really solid connections. It's got USB-C, if you didn't see that. Like, so good. A nice like metal housing as well, which is an optional add-on, but still looks cool. And it's very like great for me, because as you'll see in a sec, these will be bombarded by balls. Also, just as a quick little tangent, I have come to love Molex over JST. I have had to do a lot of cable crimping over the last couple of days. I've had a couple very late nights of cutting cables and crimping. And I've come to really like Molex. Molex are good. They're just so much bigger, so much easier to crimp than the JST ones. So I'm a big Molex fan. Another thing on the Pros, the web interface is so good, and it actually works on Windows 10. Previously, I couldn't get any of the like visual stuff working for the old ODrives on my Windows computer, but it just works. You just plug it in and it just goes. It just works. And you can do really basic control. Setting up the ODrives is so quick. They've got a really nice GUI for it. Honestly, so good. And anti-cogging works. So I'm very conflicted about this because it means it's going to be a lot of work to do this, but anti-cogging basically allows you to control the motors really, really slowly. If you try to do this without anti-cogging on or like active, then the motor tends to just like jump. It will like move a little bit and then just skip, and the motion will be really erratic. But with anti-cogging on, they can control the motor really smoothly at still a very slow speed, which I'm really excited about, because it means that I'll be able to use Jugglebot in like the Stuff Made Here style, like edutainment video. I'll be able to move Jugglebot really slowly, and I think that will look very, very cool. Whereas previously, like you've never really seen Jugglebot move slowly in a controlled way, because I've never really done it, because the actuators previously could never do it because they weren't able to be anti-cogged. But now that they can, it means I'll be able to move it really slowly. But this process means that I'll have to separate the motor from the linear actuators, which will probably mean having to restring all of the linear actuators. So I'll have to de-string them, separate the motor out, do the anti-cogging process, not touch the encoder that's attached to the motor at all. I don't even know what's really connected there, but like leave it alone as much as I can, and then restring everything, which is, I think that'll be a full day in and of itself, but I think it will be worth it, because having a nice, slow, smooth control will be so sick. Yeah, let's move around. And there's an inbuilt absolute encoder in these ODrives. So down the bottom here, it's actually not, I found it really weird. It's not clear in the docs where this encoder actually is on the board. Like when you get the case, it's pretty obvious because it's the only thing right in the center there. But if you're curious and you want to get these, the absolute encoder is straight in the middle. And that's really good. It means that there's a lot less wiring to do, and this is an absolute encoder, which means that it remembers its position even when so if you turn everything off and I move the actuators around and then I turn everything back on, these will know where they are within one revolution. So I'm still unsure of how well I can use this because of that like one revolution play, because I will not always be finishing a session of the robot with it ending in the exact same position, and I don't really want to have to like move it into the right position before starting the next session. So I'm not sure how much I can use this right now, but it's a very, very cool feature. And there's so many more. Honestly, like I've just been finding myself getting constantly excited about these ODrive Pros for like the last 3 weeks, ever since they arrived, and they're so good. But the transition is slow. It takes a long time to redo all of this wiring, particularly because the Molex and the JST clips are so goddamn tedious. And there are some cables that I was doing, like for the encoder cables, that were going 5 cables, JST on one end, Molex on the other. And thankfully this never happened, but I was very conscious that it can, because I've done this in the past, where if you finish all 5 on one end and you finish all 4 on the other end, and then you screw one of them up, if you screw it up badly enough, too bad. Do the whole cable again, or at least do that whole end again. And yeah, that can be pretty heart shattering. But anyway, they're all done now. And this is actually not quite true because I've updated this since then, but there's a very, very small amount of transition time left. And this is what I want to show you now. No more spoilers, so I can show you how everything's all set up. So, where do we start? I don't know. Yeah. So, it's all a bit messy right now, but it will be a bit tidier soon. So we've got all of the 6 ODrives around the base. These are currently numbered with just masking tape. Yeah, the wiring is, how do I even show this? I don't know. So we've got a CAN bus line. Here is my input that I'll be plugging into my Jetson computer. This CAN line just kind of like bounces around off of all of them. And as I said, these connections are so good, so satisfying to clip in and clip out. And these cables, again, these CAN cables took quite a while to make, but they're done now and they seem to work, so that's great. The other thing that will be different is that this hand motor, this is the setup that I was describing before. So we've got the motor with the drum. And actually, John, if you're still on now, I have seen your Zulip message and I need to reply to you. I've been a bit busy. But I want to send you the CAD files that I made for this because it was a little bit tricky to mount the motor in such a way that I could make use of the absolute encoder. I've had to be a bit sneaky, and honestly, it feels a bit dodgy because the magnet that's on the back of the motor, it kind of like wobbles a little bit when it's spinning really fast, but it seems to work. So yeah, I'll send you those files and hopefully we'll be able to recreate the same thing. Yes, but in the future, this hand motor will not be here. This will instead be up here, attached to the bottom of the platform. So this won't be here anymore, and this power situation will be a little bit neater. And you will see that I am now using bus bars. So this was my journey last night, was making all of these cables. And these are all very solid. So these cables are not coming out. They are very firmly screwed into the blocks on the ODrive Pros, so hopefully we do not have the same problem as last time where they come out. I've also, you notice I've used a thinner gauge wire. I came to learn that the 10 AWG wire that I was using is a little bit overkill for my current setup. So I'm using 14 AWG wire, which should be completely fine for the power that I'm drawing. Yeah, it's looking pretty cool. I'm pretty happy with it. It might actually make a bit more sense. I can show you in the CAD how things are wired. This is the first time that I've drawn the wiring out in the CAD. And I think it helped a lot with kind of mapping out where everything goes. So the purple wires are the CAN, and black and white are obviously, black and red are obviously power. And this is something I haven't put on yet. They're out in the kitchen, I think. I've made these little shrouds just to like cover the cables, and partially to protect them, but also partially because I ran out of black heat shrink when I was making this. And so all of these cables have to be terminated with the blue heat shrink, which if you look at it from a distance, I mean, it's a little bit harder to see now because all of the power cables are really messy. But once they're tidied up, the blue, in my opinion, stands out quite a lot. And I don't know if I really like it. So I figure these shrouds will do a good job of just covering that up and keeping everything color coordinated, which is very important. Yeah, cool. So I do have one other question, because this is regarding power. So let me show you the actual robot. So can I put this? Oh, I need more of these cameras just to like set up in a permanent spot around the room. This should work. Yeah, that's good. Cool. Okay, yeah. So these power buses that I've got here, I was originally intending on keeping this, like the main power line, at 45 volts, which would mean that all of these, like the big leg motors, will be getting 45 volts, which is totally within their spec. And my intention there was just to like basically give them more power and more like force. However, the hand motor is only rated for 3 cell, which is like 21 volts or so. And I haven't yet tested it at 45 volts. This is something that I have been meaning to do, but just haven't gotten around to yet. I did make it smoke at one point because I was trying to see how much torque it could output while I was just like holding the motor, and it was smoking. And I'm not too keen to like make it catch fire or like burn anything because it's so closely and so firmly fixed onto the ODrive, and I don't want to break the ODrive. So I'm considering making like a quick release system to really easily separate the motor from the ODrive, so that way I can really push it, and then if it does like catch fire or something, I can just quickly rip it off. But for now, I haven't done that testing, and so I'm considering I've got 2 options. One option is to get some sort of buck converter to convert from the 45 volts of the main bus to the 21-ish volts of the hand motor. But I don't really like that because it's just like another thing to make mess around the base. So my second option is to run the entire system at the 21 volts of the hand motor, which is fine for the legs. It just means that they will be less punchy than they would otherwise be. But I think that should be fine because the whole platform isn't actually going to be doing a lot of like work, like especially each individual leg is not really going to be doing that much work because that only just needs to move side to side, while the hand motor is the one that's doing like the main kind of pushing. So I'm considering just making the whole thing 21 volts and then being done with it, but I don't know. I'm not sure. And I do also actually have another, while I'm on the topic of electrical questions. Oh, John's replied. For some reason my chat doesn't like sync up properly between OBS and the YouTube one. So John says, sounds good seeing a hand motor. Nice. Go for 44 volts. All right. Motor will be fine at high voltage. Yeah, okay. I thought so, but I'm a little bit worried about overheating. So I mentioned this a little while ago where, from my understanding, the biggest problem for me with running at a higher voltage will be higher heat. And I'm now, after having the motor smoke, I'm a little bit more worried about heat than I was before. Especially if this motor is going to be like in the platform. If it heats up in a dangerous / like explosive way, it will probably wreck other things. So I'm a little bit cautious of that, but yeah, all right. Maybe we can just YOLO it. I don't know. I'll try to make some sort of quick release thing, but we'll see how we go. Yeah, so there's one other question that I have on electrical stuff. My computer keeps like shutting down, and I don't know why. Like at night, it just turns off. So you just have to give me a second while I find this. Oh no, it is open. Yeah, cool. All right, so this is my current plan for the wiring. This is the main reason why I haven't gotten everything hooked up right now to work now, is that I really don't want a repeat of what happened last time. So I'm being very cautious to do everything right. And yes, so something that I have discovered recently is that the Jetson can run on 12 volts, which is exciting. It can run between 9 and 20 for anyone curious, which is exciting because the ODrive Pros, if you run, they have 4 spots in their CAN connection. I don't really need to see it, but there are 4 spots there. 2 are like CAN high, CAN low. Third one is ground, and the fourth one is 12 volts. And that 12 volts is used in the ODrive to let you communicate with the ODrive when it's not even on, which is so good. I anticipate this being quite helpful with like when the robot's actually moving around, because I'll be able to have the motors off, but the ODrive's on, so I can like tweak them, read their errors without having to turn them. Like previously, whenever I like hit the e-stop because something crapped itself, all of the ODrives would turn off, and I would have no insight whatsoever into what the errors were that caused the problem in the first place. But now, the ODrives will still stay on even once I turn the motors off, which is so great. And yeah, so that's running at 12 volts, and the Jetson can run at 12 volts. So I'm thinking of setting things up like this, where I have the 12 volt power supply that I'm thinking of running, like it'll be a high enough amperage, it'll be fine. That will power the Jetson, and then that 12 volt line will go into the CAN line. So the CAN bus will consist of the pink, the black, the green, and the yellow, and that will just run around to all the ODrives. I only have 3 here, but in reality, we have 7, but honestly drawing this out in this program takes too long, so I'm not going to do that for all 7, but you get the idea. So the thing that I'm concerned about is that I need to make sure that the ground of the CAN bus is the same as the ground of the power bus. This is what I didn't do right previously, I'm pretty sure. Well, this is what I didn't do right for a long time, which was causing a lot of headache. I then fixed it, and then things broke again. So I want to make sure things are good. So my options, as I see it, are either connect the power supply. This is currently a 48 volt one, but I mean, as John is suggesting, I can just go the 45 volts. But whatever I use, the power supply will be here, and I'm fairly sure even my 24 volt one is isolated as well. So this will be isolated. So I'm thinking of putting the 12 volt power supply that will go into CAN and the Jetson plugged into the same power board as the main power supply, and then kind of like circumvent the isolation of this power supply just by having a wire go from like ground to ground, just like over the power supply basically. Which feels a little bit sketchy to me, but I don't really know what I'm doing, so I don't know if it actually is or not. So that's option 1, is to just like circumvent the isolation. And then I just have to really make sure that these are always plugged into the same power board, because otherwise those grounds will be completely different. Or option 2 is to grab this ground line from the 12 volt line and just like find a good spot to like sync that up with this ground line coming out of the isolated power supply. So one option for that would be to chuck it into the bus bar that I've got there with like all of the grounds. But I don't know. If you have any thoughts about if both of these options are legit, then that would be fantastic, and I would love to know, please. If one is better than the other, obviously I would like to know that as well. Just, yeah, any thoughts whatsoever on getting this routed up. My inclination right now is to do the bypassing the isolation of the power supply and then just making sure that they're plugged into the same power board. That feels like it'll be neater, just because I can't think of a really nice, convenient spot to link up the 12 volt ground to the main like motor ground. There's not really like a nice, like just like topologically, there's not really a good spot for that. But I'm happy to do either, especially if that way is more legit than bypassing the isolation. I would prefer to do the more legit one. But yeah, that's the plan, at least. So we'll see how we go. And what's next? Yes, the very, very exciting platform mounted hand motor. This is, actually before that, regarding catching, I wanted to give a shout out to Jon. Jon on Zulip has been very, very helpful. I'm keen to see where this goes. Jon is also making a hand to test like the catching and the throwing, like what I was showing before, where you like lower the torque, have the ball come in, and then like raise the torque and then throw the ball. There's a lot of different ways of doing this control algorithm, and Jon is setting up a rig of his own just to like do this one axis catching and throwing. And I'm very keen to see where this goes. And I like when people build stuff that's like very closely related to what I'm building. It's really cool. I'm very glad to see it. I'm keen to see where this goes. Regarding power, Jon says the right answer is to opt to isolate the CAN lines. Ideally, that would be integrated with the motor drives. There are small isolated boards that will work. Interesting. So you're saying have this bit be isolated? So what I'm going off of is this. I've actually got it open. Look at that. I'm going off of this diagram, come on, that they've got on the ODrive docs, where we've got all of our ODrives strung up. I don't have a battery, so that is a little bit different. Like, I don't have all of my power supply coming from one spot, which I think is where this is a little bit, I don't know, different. But yeah, I'm trying to mimic this as closely as possible. So I want my logic / can ground to meet up with the ground of everything. And yeah, that's kind of what I'm going for. And I don't know if I can isolate the can lines. I'd have to buy a different board to isolate it from the Jetson, because the Jetson right now is just on like a basic, like, it's effectively the same thing as this little board that I showed before. It's just like a basic like CTX, CTR thing. Yes, I'm not sure if I can isolate that easily, at least. And I'm pretty sure the ground of the can line should still be connected to the ground of the main stuff. I'm pretty sure, but I also don't really know what I'm talking about, so could be that. But anyway, yes, so the next thing, so once all the power is done and sorted, I think that I will need to change my code around a little bit, which is a little bit annoying, but I think it's a good type of annoying, because the ODrive people have made a CAN bus library to work with ROS2 with the ODrives, so that you can very easily just like port in this node. I actually don't know, I haven't looked into it super closely yet, but they basically made a way for you to connect the ODrives with ROS2 over CAN very easily. But of course, I wasn't using that before because it doesn't support the old ODrives that I was using before. So I basically wrote my own version of this, and I'm going to have to change things. I'm pretty sure I'm going to have to change things around to use their system, because honestly, I think their system is, I'd be a bit worried if it wasn't better than mine, because I don't know what I'm doing. And hopefully they do. They seem to know what they're doing. So I think I'll have to do a bit of like code finagling to move my old code over to the new like ODrive Pros. I think that shouldn't be too bad. It'll just be a matter of sitting down with it. But then the robot should be working, moving around with the Space Mouse, same sort of deal as we had before. So we finally be back to where we were like 6 weeks ago. But then to actually catch and throw, I really need to change this setup. So right now, as I showed you before, the hand motor is on the base. That is a very temporary thing. So there's been a bit of flip-flopping on this. Some people, like previously, people were suggesting having the hand motor on the platform, and I said, actually no, that's not that necessary, because the kinematics aren't really much more difficult having the hand on the base. But, which is true, but the new motor, to be able to throw, to be like most optimized for throwing and catching, it's better if the spool that the string is wrapping around is quite small. Like this is a 6mm radius, a 12mm diameter spool. And this is very small, which means that if this is on the base and the platform moves over to some wacky angle, this will need, the end result is that this will need more string to be wrapped around it if it is on the base than if it is on the hand. It will just have to accommodate more string, which means it will have to be much longer because it's so damn tiny that the string has to wrap around so many times. Whereas before, when I was using this big motor and a big spool, the string only wrapped around this like twice. So it doesn't really matter if it goes from like 2 to 3 times because it's nothing. But with this tiny little spool, it will go from like 7 wraps to like 12 wraps or something like that. And that's a pretty big difference. And of course, I do not want the string to like come off the end or go where it's not supposed to go. So for that reason, and also a couple others, it makes sense now to consider having the motor for the hand on the platform itself. Yes, particularly because it's small and can be very easily moved around by the platform. Like this weighs nothing. Yes, but there are of course some problems with this, some difficulties. The first is to run power cables and the CAN bus cables to this motor. So to show you what this would look like, we will have, let me put this back over here. Maybe back a bit more. I need more cameras. Yeah, so all of the main power stuff is down here for all of the leg motors, and the comms line and everything's down here. But we want to put this up here on the bottom of the platform. And that means running cables from here to here in such a way that they can accommodate the platform moving around to like weird spots. And ideally, in my mind, we would use something, come on, like this, like the telephone cables that are like super stretchy. But the CAN cable that I'm using is very thick, very not wanting to be a spiral like this. So I'm not too sure what to do there. But Peter did have a good suggestion on Zulip you can use like a heat gun or a hairdryer, and if you coil the cable around a drum, and I've got plenty of like cardboard tubes that I can use as a mandrel for this, you basically wrap it around, heat it up, super hot, and then there's a weird like reversing the coil sort of thing you have to do, and I'll explain this if I end up doing it. But apparently it's pretty easy to make a coil of cable like this. So I'm thinking of doing that with this, but I'm a little bit hesitant because this cable is fairly heavy, and I'm a little bit worried that, I don't know, maybe it's not like that heavy, but I don't know, I'm concerned, I'm conscious of the fact that making this big coil of cable that's just dangling off of the platform is going to add a fair bit of mass to what that has to move around. So I don't know. I'll give it a go. I reckon I'll give it a go. That's the best option that I've got. I can't think of any better ideas for getting the cable up from the base to the platform, other than just having like a dangling cable, but that seems a bit lame. So I don't really like that. Of course there is like wireless, but I'm not doing wireless. No. And yeah, so once the cables are done, which I really like Peter's idea, and honestly I feel like I'll probably go for that, there's still the problem of how to route the strings, particularly because we want bidirectional control of the hand. And what I mean by this is we want the hand to be similar to the legs, insofar as for the legs, if I move, wherever I move this like main rod, the motor will always move as a result. If I pull it out, the motor will spin one way. If I push it in, the motor will spin the other way. And so it's like the exact position of this shaft is keyed to the position of the motor. And I want the hand to be the same way as that. Previously, we just had the hand was pulled up by the motor and then it was pulled down by springs. And that was good, but it means that the motor is basically fighting against those springs quite often. And it's, I don't know, less easy to control, less precise, especially like if I was moving down, if I wanted to move down really fast, like faster than the springs can pull it down, I just can't do that. And it's, yeah, the springs were good, but I think having bidirectional control will be much better. So the question is, how do we do that? And I've been having a bit of a play around with this, and I made this prototype, which works a lot less well than I was expecting to, where the basic idea is, let me show you one here. The basic idea is to have the string mounted, fixed at one end, each string. The strings are perpendicular to each other. And the idea is if you pull the loose end of each of these two sides, then the thing should move up and down. However, these pulleys are not perfect, and because they're not perfect, it doesn't stay perfectly flat. And so this just, as you can see, doesn't really work. And it gets tangled up very easily. So that didn't really work. So what I'm thinking is we've got a setup that looks like this, where we want the hand motor to be on the platform here somewhere. I'm still not sure if I want it to be this way or flipped around the other way, where it's like this. I'm not sure which way I would prefer. This way feels like it would kind of eat up the stroke of the hand a little bit more, whereas if I had it this way, I can have this like really low down, and I can have the stroke of the hand be like the entire length of those carbon fiber tubes, which would be pretty good. Every millimeter more of length that we give the hand to move in means that it has more time to accelerate, and it can therefore throw the ball even higher, which is exciting. Yeah, so I'm not too sure about that yet. I also am very conscious of the fact that these motors were very arbitrarily chosen and are definitely not the perfect. Oh, I'd be very surprised if they were like the perfect motors for this spot. And I'm conscious of the fact that I will probably want to change the motor out for a more appropriate one later, which will likely be a bit bigger. So I'm keeping that in my mind, trying to set this up in a way that I can relatively easily swap the motors out. It would be ideal if I didn't even have to reprint anything and I could just take one motor out, put the other one in and go, but I'm not really expecting that to happen. So yeah, this is a bit tricky. There's a couple things going on here. One is we need to support these carbon fiber tubes or like attach to them. Another, we need to support this business with the hand motor. We also need to support these pulleys because these pulleys and their attendant strings are critical to make sure that this platform keeps its rigidity. If we don't have these strings here, then this whole whatever is attached to the bottom of these three tubes is fairly free to move around. But having these strings here and tensioned and clamped tightly, which is another open problem on Zulip, is very important to make sure that this whole thing stays stiff. So these pulleys need to be supported. They don't need to be exactly where they are now. This is with the geometry of the old bit down here, but they need to be somewhere. And then finally, we need these hand strings to somehow work. So my thinking, because that old prototype didn't work, I'm thinking of changing it around so that we have, let me show the hand. Actually, I'll just do it like this. That's not what I wanted. Let me show it like this. All right. Where did you open there? Okay. So I'm thinking of making it so that the strings, I don't want a highlighter, I want a pen. So the string will end here, come up over the pulley, come down, go through the spool. So you can see, I've got these holes that run through the spool. I'm not exactly sure if these should be directly parallel to each other. I'll have to play around with that. But that hole goes the whole way through. And the idea, in theory, is that string passes through unimpeded and then goes around some pulley somewhere, back up to the top, and then attaches back down onto the platform. Sorry, back onto the hand. So that, I just realized that was a really bad spot to have the hand for this screenshot. Let's do it like this. Okay, yeah, so the string attaches to the hand somewhere, goes up over the pulley, down through the spool, up, down, onto the other side. At least one of these ends will have a little length adjuster thing, it's the same as what I've had before. And then the other side, so this will be to pull the hand up. The other side, let's do it in green, is perpendicular to these old strings. So these blue ones are kind of in the plane, and the green ones will be we will be having them lined up with each other right now in this view. This will go down through the spool in this exact same way, just in a different hole, and then up, and then attach onto the other end of the hand. Again, with at least one of those ends having one of the length adjuster things. So the theory is that if I do it like this, no matter which way the motor goes, it's always going to be spooling one end and unspooling the other end. And my hope is that by having these through holes that the strings pass through on the spool, it will be kind of self-adjusting and it will make sure that the string stays in the middle here so it will pull equally from both ends. But I'm a little bit skeptical as to whether or not this will actually work. We'll see. But yeah, that's my running plan right now. But of course, the specific positions of all of these cables need to be very carefully managed to make sure that it doesn't conflict with any of these other things that are going on. And there's a lot of geometry in here. And I think I just need to sit down for a bit and just CAD for a little while. This is very reminiscent of this part of the legs where the strings have a lot of routing in a very small space. And this part took a very long time to model. And yeah, I'm gonna have to do the same here. So that'll probably be next week's job, I think, is getting that all set up. But if you have any other ideas for how to get bi-directional control of this guy, of course, like the carbon fiber tubes here, like I will probably change this. This was very much just like a prototypey sort of thing. But this cup part just needs to move up and down and be controlled precisely in both directions by a single motor. I know that it's possible because I've done it before. It's the same, it's exactly the same, like if you blow your eyes, it's the same thing as the linear actuators on the legs, but it's just a little bit more, there's different considerations to be made here. And there's another one still, because not only do I want to mount the hand motor and its ODrive to the platform, I want to do the ODrive as well so that I can use the onboard encoder. I also want to mount this little teensy to the platform as well. So somewhere on whatever is down here, whatever printed piece is down here, I also want to have this teensy and its CAN transceiver. This teensy, as I said before, is currently its only job is just to like monitor the CAN bus and then report how many messages are being sent on the CAN bus, just so that I can like have an idea of what's going on. But I want to put this on the platform because I anticipate wanting to have some sort of electronics on the platform itself, be it an IMU or the laser gate thing that I've talked about a little bit. But something, I'm expecting there to be some electronics on the platform, and they will need to communicate with the rest of the robot. And my plan is that this teensy will be that gateway. So by already having this on the platform, ready to go, I'll try to do it in such a way that I have access to the pins, and then I should be able to relatively easily retrofit things and add things onto this platform and just hook them up to the teensy, and then via the teensy they can communicate over CAN to the rest of the robot. So this needs to go on there too. Thankfully, the ODrive Pro has a 5-volt output, so I should be able to power this pretty easily with the teensy. I just need to find a spot for it. That's the only problem. Yeah, but thankfully, because it's so small, I don't really care too much about the symmetry of that. I think I can just kind of tuck it away somewhere so you don't really notice that it's asymmetrical. But yeah, we'll see how we go. And that's that. So it's been a lot of wiring, so much wiring. I have so much footage of me now, just like sitting here, take off the heat shrink or the sheath, strip all the wires, clip all the clips on. It's so damn tedious. But it's coming together. It's looking good. And I feel very confident that it will work well. I've also actually, I have become more grateful that I have stuck with this design rather than changing for a cable robot, because I actually think that this hand mechanism with like the long cage part that the hand moves inside and just having that one linear axis to throw and catch the ball, I think that will be very important for super high throws. I think even if I make a cable robot, having 6 motors working together, this is very closely related to what Luke said and what I showed, like the professional juggler, Luke, he said this a couple of weeks ago to me, that you basically, you want to have the most commonly done action, which in this case is to throw, being as simple, like as mechanically simple as possible. And for this like juggling robot case, that would mean having just a single motor responsible for that throwing action. So if you have a cable robot, like the Cable ND one that I showed a little while ago, that is cool and obviously works for doing low throws. Like they show that cable robot throwing to itself within its little box. But I do wonder how well that would work for doing like 5-meter throws. Like I've got this book by someone that some of you may recognize, Burkhard Polster, The Mathematics of Juggling. It's a good one, where he has at one point, at the very bottom of a page, kind of annoyingly, the height of the throw based on the number of balls. And this is obviously just an estimate. Like you can do, other one. You can do these numbers at different heights, but yeah, this is a rough estimate. And if we're going to be throwing 14 balls, where are we? 14 balls, 12.9 meters. We want to be able to throw 13 meters high and be precise, like extremely precise. Somewhere else in here he shows like what the angle is that you need to be throwing at, because if you throw at the wrong angle, like just a very small difference in the angle here leads to a big difference in where the ball lands. And the robot only has so much movement, so you need to make sure that that angle is very precise. And I do wonder how well a cable robot with 6 or 8 even motors moving the hand, I wonder how well they would be able to position that with like very, very high accuracy or precision on the angle. But I think this will work a lot better. I think especially, like, I could just make this cage thing as long as I want. I could have it be like 1/2 meter long, and it will have so, if once I get it working well, it will have so much time to get its path perfect. So hopefully that will pay off. And in any event, I'm very glad that I've stuck with this. And I think this robot will do very well. I think it's got a lot of life left in it. I'm very grateful for everyone who has suggested to me to keep with this design rather than changing over. I think it would have been a big mistake to change to the cable robot when I was originally thinking of it. Honestly, even now, I've got to keep sticking with this one. Yeah, cool. Well, that's about that. Actually, one other thing, while I've got books on my mind, someone else, I think Neil, suggested this Brushless Motors and Controllers, which is a very short book, but it's been really useful. If you know of any books or just resources in general to go over any of this stuff, I mean, anyone who's been watching this for a while will know that I've definitely been overreaching my knowledge base quite a lot in this project, and I find books to be very, very useful to learn this sort of thing, because like all of the information in this brushless motors and controllers, I've encountered it before on the internet, but just having it in like one spot and referenceable as well. If I go, oh, like what was the throw height for 5 balls? Like, fuck, I've got to find that website that I found it on like 6 months ago. Or I can just grab my book, flick to that page, boom, right there. So yeah, if you know of any other resources that you think I might find helpful, please let me know, because I probably will, and I will appreciate it. Yeah, so check out the Open Problems stream on Zulip if you are interested. I think someone actually might have signed up while I was talking about this. I got another notification. Oh, yeah, someone did. Who was it? I want to thank you. Corey, thank you, Corey. 97 now, look at that. So close. 3 more people, and we'll be on the hundy. Yeah, that's about it. Next week should be good. It's so close, so close. I think as soon as I get this hand motor part ready, we'll be good to go. But there's going to be so much more printing, because I will need to reprint, oh, come on, there you go. I will need to reprint this top part, because I'm making this just one solid part now, where previously it was 3, and I'm changing the positions of the pulleys. So that will need to reprint. That's like 7 hours, I think. This bottom part, that's going to be a big boy, and will probably be like 10 hours and potentially multiple parts. Hopefully not, but we'll see. There's going to be a lot of printing, so I don't know if this will be ready for action next week. And honestly, just designing it is going to take a while. But soon. And actually, there's one more thing I want to mention while I'm thinking about this, is that because the robot now has a separate movement and throwing action, we will be able to have a game, or like a mode of the robot, where we can control its position with the space mouse, and then have some sort of button that the harder you hit it, or in some way we can encode both timing of throw and velocity of throw. So like you hit it really hard and it goes higher, and you hit it soft and it goes lower, something like that. But some game where you can like control it, hit the button, and then throw, and then you move it to where you want to catch to, it will just handle the catch by itself because that's how it's working right now. Like we just set the torque limit low and it will just catch the ball. But I think that'll be so much fun, just like seeing how many balls you can juggle by just with the Space Mouse. And what would be really cool if we could get the lag to be low enough, we can potentially get it so that you guys can control it in the stream live. And like, I think the latency will be too big to have you do like that sort of control that I was just talking about. But I am very, very, very keen for the day when this is actually working and when you have multiple of them working well. And then in the stream, people will just be able to be like, oh, I want to see this pattern. And then they'll just change into that pattern. And then I want to see this pattern and then it'll just change. Oh, it's going to be so good. We're so close. Anyway, that's enough rambling. Thank you for joining me. I hope you enjoyed it. And good luck with everything you're doing until next week and beyond, because why not? But yeah, I'll see you all next week. Have a great weekend.